Welcome to The Explainer. Today, we're going to dive into a pretty radical new idea in AI, one that seriously challenges the very foundation of today's top models. We're talking about a potential new champion in the world of artificial intelligence. Our story starts with a fascinating paradox, a moment where the champions of AI are actually challenging their own creation. The very minds who built the dominant transformer architecture are now saying, hey, maybe there's a fundamentally better way to do this. And get this powerful statement comes directly from Sakana AI, a company co-founded by the architects of the transformer. They're basically saying their own incredible invention, while brilliant, might be a dead end if we don't start looking to a much older, much better model, the human brain.
So let's really explore this whole idea of thinking like a brain by introducing the continuous thought machine, or CTM for short. This is an architecture built on a completely different philosophy of how an AI should think. I mean, literally. A CTM isn't just an update or an iteration, it's a total rewrite. Instead of only caring about what a neuron fires, it's obsessed with when it fires and how it syncs up with all the other neurons, just like our own brains are believed to work.
So here is the absolute crucial point. For a continuous thought machine, time isn't just a sequence of data it has to process. No. Time is an active ingredient in the thinking process itself. It gives the AI its own internal clock to deliberate and to reason.
Okay, now this is where it gets really interesting. We're going to see how CTMs actually think. We're going under the hood to see this internal deliberation process that allows the AI to, think before it acts, which is a huge departure from the instant reactive models we have today. This ability really comes from three key innovations all working together. First, it has its own internal clock, these thought ticks that just run on their own, separate from any incoming data. Then, each tiny neuron has a private memory of its own past activity. And finally, and this is wild, it represents thoughts through the dynamic synchronization of these neurons over time. So this process creates a kind of continuous internal loop. Information flows in, neurons check their own personal history, and a thought starts to emerge from their synchronized dance. With every single tick of its internal clock, the CTM can refine its understanding, basically deliberating with itself before it ever gives you an answer.
So let's get to the tail of the tape. CTM versus transformer. This is where the deep philosophical differences between these two architectures become crystal clear. It's a real clash of titans.
The first major difference is just computational effort. A transformer is like a sledgehammer. It hits every single problem, whether it's big or small, with the exact same fixed amount of force. But a CTM, it's more like a surgeon's scalpel. It adapts. It applies just enough thought to solve the problem at hand, which saves a ton of energy on easy tasks and lets it dig way deeper on the complex ones. And this table just lays out the core differences beautifully. For example, just look at memory. CTMs have it at the neuron level, which allows for that internal deliberation we talked about. Transformers? They don't have that. Or look at interpretability. We can actually watch a CTM think step by step, whereas a transformer is still pretty much a mysterious black box.
Okay, now we're putting CTMs to the test because, a new architecture is only as good as its real-world performance. So how do they actually do on tough problems? Well, let's take a look at the results.
In a really complex maze navigation task, working directly from raw pixels, the CTM is just in a league of its own. It hits an 80% success rate. That's nearly doubling the performance of older, respected models like LSTMs. It's not just solving the maze, it's showing a much deeper kind of spatial reasoning. But what's truly mind-blowing is how it solves problems. When researchers asked it to identify a gorilla in a picture, they could actually watch its attention. And first, just like a human would, it focuses right on the eyes. And then, its focus shifts down to the nose and mouth. This emergent human-like strategy wasn't programmed in. It learned to do that. This gives us this incredible window into its reasoning process, making it so much less of a black box. And this is crucial. A CTM knows what it knows. This number, 0.15, is its calibration error, basically a measure of how trustworthy its confidence is. A lower score is better, and for comparison, we humans score a 0.22. This means a CTM is actually better at judging its own accuracy than we are. Just think about that for a second. So let's bring this all together and talk about why this new AI really matters.
because the stakes here go way, way beyond just building a faster, better model to top the leaderboards.
The CTM advantage really boils down to 4 things. It points toward AI that is way more efficient with its energy, far more trustworthy because we can actually understand its reasoning, more capable of complex, multi-step planning, and, maybe most importantly, it's more plausible. It's more aligned with how intelligence actually evolved in nature.
And this leaves us with a final, really provocative thought. For years, the path forward in AI has seemed pretty clear. Just build bigger and bigger transformers. But the continuous thought machine asks a totally different question. What if the next leap forward isn't about getting bigger at all, but about learning to think in a completely different way?